All right, in this video, I'm going to go over a couple of perimeter word problems. Perimeter is the distance around an object. So, this word problem is saying the perimeter of a rectangular outdoor patio is 54 feet. Well, they just gave us the perimeter. Wow. The length is 5 feet greater than the width. What are the dimensions of the patio? Okay, I see what they're doing here. They're wanting us to start with the perimeter, and they want us to get the dimensions of the patio. So they want length times width, whatever by whatever. Now, but it's not really times because length times width of a rectangle is actually the area. So they just want length and width. Whatever. Okay, so we have the perimeter already, which is 54 feet. Well, that was easy. And with problems like these, I like to draw myself a picture. It just helps visualize it, you know. We don't know what the width is, but we do know that we want to represent it with a W. Again, just to make sure we're clear on what's W and what's L. L is length. So the length is 5 feet greater than the width. So the length is, equal sign, is 5 feet greater than the width. So width plus 5. Makes sense? Yes. It's exactly what it is. The length is the width plus 5. And this is the length too, by the way. So, what are the dimensions? Well, how are we going to figure that out? What is the formula for finding the perimeter? We just add all these together, right? Perimeter is W plus L plus W plus another L here, right? Well, there's two L's and two W's, and we can combine those, right? Because they have this understood 1 in front of them, and you can combine those coefficients together. So perimeter is 2W plus 2L. That was a bad L. Okay, not bad. Good start. We know the perimeter, that's 54 feet. But we don't know W or L. How are we supposed to find either one of them? Well, we do have a relationship between them, and we can substitute this in for L since it's equal. So we can leave the W, 2W. We can add 2L, but L is also W plus 5. And since we have L in terms of W, we can do that. And now our only variable in this entire equation is W. So now all we have to do is solve for the unknown variable. Now, parentheses matter when substituting. If you didn't put parentheses around this, you might just say, 2W plus 2W plus 5. That is wrong. Absolutely wrong. Wrong. You got to distribute that because it's not 2 times W. It's 2 times W plus 5. We're adding this twice. You see, when we're adding all that perimeter together. So that's why you distribute the 2 to the 10 to the 5. So you can 2 times 5 is 10. Right. Okay. Anyway, all that adds together to get 54. So, 2W plus 2W. You can combine that, right? That's 4W. Subtract 10 from both sides. Okay. 4 equals 4W. Okay, divide both sides by 4. 44 divided by 4 is 11, right? 11 what? 11 feet. Gotta remember what your units are. In this case, we're using feet. So the width is W. Okay, width is W. The width is 11 feet. Okay, we got part of the answer. Well, the length is 5 feet longer than the width. So what's 11 plus 5? 16. 16 feet by 11 feet. And there's your answer. All right, I got another perimeter word problem for you, but this time we're dealing with circumference. What is circumference? It's the perimeter of a circle. Well, first off, let's read the problem. A mall complex wants to build a merry-go-round that is 50% greater in circumference than another competitor's merry-go-round. The competitor has a diameter in their merry-go-round of 10 meters. Okay, we'll underline that. What does the diameter of the new merry-go-round need to be? Let's also underline 50% because that's important too. How do we calculate that? So we have a merry-go-round here, and we want to build one that's 50% longer, greater in circumference than the competitor. Okay, well, first off, let's make sure we know this formula. Circumference of a circle is 2 times pi times r. What is r? R is the radius of a circle. What is the radius of a circle? Well, it's half the distance of the diameter, right? The diameter is the whole length of the circle, but r is just from the outer edge of that circle to the center. So r is 1/2 of the diameter. Okay, so what do we know? Well, we have the diameter of the competitor's merry-go-round is 10 meters. Okay, well, from that we can figure out the radius of the competitor's merry-go-round is 5 meters. Okay. What else do we know? Oh, they want it to be 50% greater. Ooh, this is tough here. They want circumference of the new merry-go-round to be equal to the competitor's merry-go-round circumference, but greater than by 50%. Okay, well, 50% is, what is that in decimal form, right? Because we need a number here. We can't just multiply it by 50. It's not going to be 50 times greater. It's only 50% greater. So to change that into a decimal, multiply it by 100, and we can just move that decimal over twice. 0.5. Okay. So we multiply this by 0.5. Wait a minute, that's not right either. Because multiplying something by 0.5 will just give you half of that. We don't want half of that. We want it to be half greater than that. So we add another circumference of the competitor. Does that make sense? We want our new one to be larger than the competitor's merry-go-round by half of the competitor's circumference. Does that make sense? And you can combine these like terms into one, and say the circumference we're looking for is 1.5 times the circumference of the competitor's circle, or merry-go-round. All right, well, we have the radius of the competitor's circumference. So we can actually find the competitor's circumference there. And what are we looking for here? We want the diameter of the new circle. Okay, so we need to find the radius of the new circle first, and then multiply that by 2. And then we'll have the diameter of the new circle. Okay, of the new merry-go-round. Whew, with me so far? So, we know that the circumference of the competitor circle is 2 pi times 5 meters. So, we can just say 10 pi. You don't even have to multiply that out and get a decimal. You can just leave it in terms of pi, because pi is this crazy number that goes on forever and ever and ever and ever and ever. And we don't worry about that because we're going to just substitute this in for that anyway. Okay. How does that help us? Because now we get the circumference of the new one is 1.5 times 10 pi. That's just 15 pi. Well, they're not asking for the circumference of the new merry-go-round. They're asking for the diameter of it. So we don't need to multiply 15 times 3.14, blah, 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 blah. So now all we need to do is use this to find r sub n. So we use this formula once again. 15 pi now is our c, equal to 2 pi. Oh, I just wrote the pi first. Equal to 2 pi. This is what happens when I get excited. I'm going to solve something. 2 pi r sub n for the new merry-go-round. Okay, well, now we're solving for r, right? That's our only unknown right here. So we divide by 2 pi, and look at that. The pi's cancel. Pi divided by pi is just 1. So 15 over 2 is what? 7.5 meters? Oh, we're not done yet, though. They're asking for the diameter, not the radius. So 7.5 times 2 is 15. So when they build their new merry-go-round, they need to make it 15 meters long.